Hello, so I'm going to show you how to measure the base pairs based on the distance of the restriction enzymes on the plasmid, the circular plasmid DNA. So I know that a lot of people are confused. And then also I want to preface this by saying I did learn this from another class, so I mean it's possible that this isn't how he wanted it done, but he didn't really give any explanation, so I did it how I know how to do it, and this what I'm going to show you is the approach I used. So just to start off, just to show you, this is the plasmid, which has circular DNA, which is this whole thing right here, and then each of these are restriction enzymes. If there is a restriction enzyme that appears only once on here, like you see this one appears several times, like also over here, I think, yeah. So that one appears multiple times. So if there is one that appears only once, I'll just say this one, I don't know, I'm not gonna look through the whole thing, but if it does appear only once, that means it gets cut only once. This is basically math of a circle. That's what my genetics professor said. So when it gets cut once, it's like a rubber band, and then you cut a rubber band, it just kind of falls, but it doesn't change its length, like its actual length. So that's why when you cut it once, it's still going to be 10,400 base pairs because you didn't cut anything out. But if it is cut, more than once, like this, then you're cutting this, and you're cutting this, or whatever, but it is all gonna, in the end, equal up to the full length. So, yeah, that's just like an explanation of how it works, kind of. So, anyway, you're gonna need a calculator, and I would recommend, multiple colored pens or highlighters. Yeah. So right here we see that this restriction enzyme equal R1 right here is 10,400 base pairs, which is the same length as this one, which means basically the zero marker would be right here, right after that 10,400. So it's basically 0, and then this would be, 5 something probably. Anyway, that's not really important. So I'm gonna do 3 different examples just to show you. I'm gonna do one with 5 fragments, one with 3 fragments, and then one with 3 fragments but from 2 different restriction enzymes, just so you can see how it works. So the first one I'm gonna do equal R1. So this is why I said I recommend a highlighter or some sort of highlighter or colored pen. It makes it a lot easier to see. And I did already do this earlier, so I already have the answers. I'm missing one. There's 5, 1. Oh, it's right here. Jeez. Okay, so that's the equal R1. I'm going to use a green pen just to stay, consistent. Okay, so I start here. So like I said, this is the 0 marker, so that's 0 base pairs, and then anything past this would be more, and then we know this is the very end. So you start with the highest one, and I'm going to keep the colors the same just so you can see. So we do this 10,400, which is this one here, and then we're going to subtract 7,200 from that. So then just so you can kind of see what exactly I'm saying, I'm measuring the distance from here to here, from this equal R1 to this equal R1, and then I'm going to measure the distance from this equal R1 to this one, and then this one to this one, and then this one to this one, and this one to this one. So that's why there's 5 fragments. So you're going to have to do 5 math problems. Okay, so this is the first one. Like I said, this one, 10,400 minus 7,200. Then you're going to measure 7,200 minus 6950, which is this one. Then 6950 minus 6,400. And then 6,400 minus 2,000, which is over here. So then this is the last, or the most confusing part, in my opinion at least. So we have all these that we did, so I'll just write the answer just so you can see. I'm going to write it in black because it's technically not the eco R1 anymore. So then obviously you just want to punch this into your calculator, and I did only do this math once, so feel free to double check me, but I did double check while I was doing it, so hopefully it's right. But anyway, so these are the four. So this one is from here to here, this one from here to here, etc., whatever, just so you can kind of see what's happening. And then you take the 10,400, this is this base pair. It just so happens that this is also 10,400, but that's not usually the case, at least in like the problems I've seen before. So typically this will be different. So yeah, but for this specific problem, this map I found, it is actually the same. So it's 10,400 minus the largest plasmid. So you're basically subtracting from 0 to here, which like normally if it was less, it would be like here to here, so it would be like this. It doesn't really matter though. It just follow the math, I guess. And I won't explain it so much. I'm just trying to explain what's going on with the math. But when I do the next one, I won't explain it as much, just so you can kind of see. Okay, so you subtract it, and then it equals 0, obviously. But then you add the smallest base pair that you had, which was the 2,000 right here. So you add the eco R1 2,000, and you end up with 2,000 base pairs. So all of these, this, and this, not that, don't do that. These are gonna be what go on your map. So just keep that in mind. And then there is a way to double check just to be sure. You can double check your math to make sure that you did it right by taking the plasmid base pairs, which is 10,400, and subtracting each of these. So you subtract the 3,200, 250, 550, and 4,400. You don't subtract the 2,000, but in the end this will equal 2,000. So this is just to double check so your answer is right once you do that. And if you want to, take a screenshot right now, because I'm going to erase this and show you the next part. Okay, I'm going to erase it. So the next one I'm going to do is the PSTL enzyme, restriction enzyme. There's 3 of those, so it is a little bit different, but I wanted to show just like how it looks with like a smaller one and one that's not all the way over here at the, the 10,400. So it looks a little different. So it's the same thing, but instead of measuring from here, because like I said, this one just so happened to be 10,400. So you're going to start from here to here, then there to there, and then there to there, basically. So there's 3. So you're going to get 3 fragments. So the first one's that minus 7845. And then you have the 7845 minus the 6245. Then you have the 10,400 minus the 9668. So then this was 1823. This was 1600. This was 732. And then don't forget, you're not done. You have to add the smallest one, which is this one again, which is 6245. And so the answer for this one is 6977 base pairs. And then again, you can double check by doing the 10,400 minus the 1823 and the 1600, and again, don't subtract this one, and you will end up with the 6977 base pairs. So that's how you can just double check to make sure you did it right. So again, I'm gonna erase this. I'm gonna show you the one with the 2 different enzymes. It is basically the same, but it might look a little more confusing since it is more than one enzyme. So I chose the BSTXI, which is this one. Oops. This one and this one. So there's 2 of those. And then the bum high. The bum high, which I put over there. Just do purple. So let's see. Okay, so it's the same thing again. You're measuring from here to here, here to here, and then here to here. So first I'm going to start with the purple. 8117. This is this one. Don't forget, it's 2 different ones. But like I said, it doesn't matter. The process is the same, but I'm gonna color coordinate just so you can see. And then it goes to this one, which is 3350. And then you have the 3350 minus 2650. And then you'll have the 10,400 minus the 8117. So then this was 4767 base pairs. This was 700 base pairs. And then this is 2283, but don't forget you have to add the smallest one, which was the 2650. And it ends up with the 4933. And then again, of course, you can subtract them just to double check. And you end up with the same 4933 base pairs, so you know that you got it right. So now I'll show you how to put on the map. It's really, really easy. It's just like a graph. So I have them all here. So the highest one, well, we'll just put, just for fun, I guess. I don't know. No, I'm not gonna put that actually. So we'll just do it like, I think the highest one I have is like 7,000. So I'll just start with 8,000. So we'll do 8,000 base pairs here. And then about halfway down will be 4,000. So this will be like 6. and then 2, and then there is like a 500 and a 2 something, so I'll just do that too, just to so we could see. So I had already written down the other ones on my other piece of paper, but I'll just write them down here. So this was from the first restriction enzyme, the, what was it called? The eco R1. So we'll put that here. Eco R1. And this is just so that I don't have to keep going back and forth on my page. This was the other one, which was the PSTL, I think. And then the last one, I don't remember what it was called. It was the BSTXI, and the other one I don't remember. So we'll start with this one. So first we have the 3200. So obviously you just want to go somewhere between here, which would be like 3000. So this is like probably 3200, like right here. Then 250, obviously, like right here. And then 550, just a little bit above the 5. And then 4400, like a bit above the 4. And 2000, we have a marker there. So then you do the same thing here, was 1823, so it's just a little bit below 2000. And then 1600, like a little bit below as well. And then almost 7,000 we have, so like right here. And then the last one was 4767. So it's like almost, it's like here, I guess. It's kind of hard to do on the iPad, but you get it by now. And then this one, just like a bit below 1,000, and then this one is like almost 5,000, so we'll just put it here. So yeah, that's it. It's really easy, but if you don't know how to do it,